As It was the biggest hit of the album, Harry's House from Harry Styles. In the music video of the song, we saw Harry Styles and his love interest on top of a rotating platform called a turntable. Moving on a turntable allowed Harry Styles to experience uniform circular motion. If you have been to an amusement park, rides like Ferris wheel and the carousel allowed us to feel it too. There are objects around us that moves in the same way. The hands of the clock undergo circular motion. So are CDs, DVDs, or records when put in their respective players. In this unit, we will study the mechanics of rotational motion. Firstly, we want to compute for the speed of an object if it is no longer moving in a straight line but in a circular path. To do that, let's start with circles. A rectangle has length and width, but a circle has a diameter. A diameter is any straight line that passes the center of the circle and ends on its two edges. Another way to describe the size of the circle is by stating its radius. The radius of the circle is a straight line starting from the center and ending to the edge. The radius r is half of the diameter d. In equation form, d is equal to 1/2 r. In rectangle, adding the two lengths and the two widths will give you the perimeter. This is the total length of the outside of the rectangle. Meanwhile, for circles, the total outside length is called its circumference. If you have a circle made out of wire, straighten it out until you form a line, then measure this length using a ruler, you are getting the circumference. However, you can use this formula to compute it. Circumference is equal to 2 pi times the radius, or c is equal to 2 pi r. Of course, the value of the constant pi is equal to 3.14. So, if the average distance of an object or average speed of an object moving on a line or its linear speed is computed this way, then the linear speed of an object moving on a circular path is simply equal to the circumference divided by the time. You can also refer to this linear speed as the tangential speed. This is because when an object is moving in a circle, its speed is tangent to the circular track. As you can see in the animation, the blue and the pink arrow representing speed intersects the circle only once, so it is tangent to it. The direction of the arrow is also ever changing. In the previous equation, we represent time as t or the period. The period is the time it would take an object to make one complete cycle around the circle. For example, in a normal year, the Earth revolving around the Sun has a period of 365 days. Meanwhile, the Moon takes about 30 days for it to make one full cycle. If in the music video, Harry's turning table has a circumference of 4 meters, and he can walk around it in 4 seconds, his tangential speed is 1 meter per second. If we look at the formula again, one important observation is that tangential speed depends on r, or the radial distance, the distance of the object from the axis of rotation. So if I were to ask you which between the green bug and the ladybug is moving faster, which would you say? Or do they have the same speed after all? Looking closely would reveal to us that the further away an object is from the axis of rotation, the greater its tangential speed is. So in this, the green bug in the outer radius is moving at greater speed than the ladybug in the inner radius. If this is a little bit confusing, let's take a look at this human demonstration of tangential speed. In here, the demonstration started with just one person rotating in place. Notice too that the first person is rotating at roughly the same speed all throughout. But as each person is added to the chain, the next person has to make larger strides just to keep up with the rest. The last person is even running since he has to cover the larger distance over the same period of time than the others. Remember, the initial speed depends on how far you are from the axis of rotation. In summary, in circular motion, linear speed is computed by dividing the circumference of the circular path with the time. Linear speed is also referred to as the tangential speed. The tangential speed depends on the distance of the object from the center or the axis of rotation. The greater the distance is from the center, the greater also is the tangential speed of the object.